Hello, my name is Lutz-Chiorean, and in this video I will be focusing on solving trigonometric word problems. A trigonometric word problem is a word problem that requires aspects of trigonometry to solve. The trigonometric word problem we'll be solving today involves sinusoidal functions. A sinusoidal function is a periodic function whose graph looks like smooth symmetrical waves. It can be created by transforming the graphs of y equals sin x and y equals cos x. In this video, I will walk you through question number 6 on page 361, section 6.6 in the grade 12 Nelson Advanced Functions textbook. The question is, to test the resistance of a new product to temperature changes, the product is placed in a controlled environment. The temperature in this environment, as a function of time, can be described by a sine function. The maximum temperature is 120 degrees Celsius, the minimum is negative 60 degrees Celsius, and the temperature at T equals 0 is 30 degrees Celsius. It takes 12 hours for the temperature to change from the maximum to the minimum. If the temperature is initially increasing, what is the equation of the sine function that describes the temperature in this environment? I will now reread the question and highlight key points of the question that will help me solve the question in yellow, and highlight what the question is asking us to do in blue. To test the resistance of a new product to temperature changes, the product is placed in a controlled environment. The temperature in this environment as a function of time can be described by a sine function. The maximum temperature is 120 degrees Celsius, the minimum is negative 60 degrees Celsius, and the temperature at T equals 0 is 30 degrees Celsius. It takes 12 hours for the temperature to change from the maximum to the minimum. If the temperature is initially increasing, what is the equation of the sine function that describes the temperature in this environment? In the question, it tells us that this sinusoidal word problem involves a sine function. Therefore, I don't need to figure out whether the equation of the sinusoidal function will be a transformation of the graph y equals sin x or y equals cos x. I know it is a transformation of y equals sin x. A basic sine function is a trigonometric function that starts at the equation of axes and is either increasing towards the maximum in the case of y equals sin x or decreasing towards the minimum, as is y equals negative sin x. This question is asking us to determine the equation of the sine function within the sinusoidal function. Here is how I plan to solve this problem. Step 1. Determine and organize given information. Step 2. Draw the graph of the sinusoidal function. Step 3. Determine the equation in terms of sine given the sinusoidal function. Step 4. Therefore statement. Step 1. Determine and organize given information. I will now pick out the key points highlighted in yellow and write them in point form to organize all the information. So here's what we know. It's a sine function. Its maximum is at 120 degrees Celsius. Its minimum is at negative 60 degrees Celsius. At T equals 0, it is 30 degrees Celsius. It takes 12 hours to go from the maximum to the minimum, and the temperature is initially increasing. Step 2. Draw the graph of the sinusoidal function. To draw the graph of the sinusoidal function, we will follow a few set of steps to make sure we are correct. Step 2.1. Set up the outline of the graph. Step 2.2. Figure out whether the graph will be fx equals sin x or fx equals negative sin x. Step 2.3. Determine the y values. Step 2.4. Plot given points. Step 2.5. Determine the x values. Step 2.1. Set up the outline of the graph. To set up the outline of the graph of the sinusoidal function, we will draw an x-y axis graph like so. The x-axis will represent time and therefore will stop at 0 since time cannot be in the negative. The y-axis will represent the temperature and will have points in the positive and the negative. Step 2.2. Figure out whether the graph will be fx equals sin x or fx equals negative sin x. We were told in the question that the temperature is initially increasing. Looking at the two possible sine graphs, we can determine that our equation will involve fx equals sin x because fx equals sin x is initially increasing. Step 2.3. Determine the y values. Based on the information in the question, we can tell that the y-axis will have 4 distinct values. 120 degrees Celsius because that's the maximum, negative 60 degrees Celsius because that's the minimum, 30 degrees Celsius because that's where time is equal to 0, and 0 degrees Celsius because that's when the temperature would be at 0. Step 2.4. Plot given points. From the information given, we can already determine a point. When time is at 0, the temperature is said to be at 30 degrees Celsius. Therefore, we can plot the point 0, 30. To determine the next points to plot, we must first look back at the graph of fx equals sine x. What do you notice? You should have noticed two important factors of the graph fx equals sine x. 1. The graph has 5 main points, which are extremely crucial. And 2. Each main point lies an equal distance away from each other on the x-axis. These two factors apply to any transformation of fx equals sine x. Therefore, it would apply in this situation, and we must take it into consideration. Looking back at our graph, and using the two important factors we just learned, we can determine where to plot the next points. We already have the first crucial point at 0, 30 to get us started. Remembering that we are increasing, the second crucial point will be at the maximum, 120 degrees Celsius. We'll plot the point at y equals 120, and on the x-axis, we'll add a tick underneath the point, but just leave the value blank for now. To plot the third crucial point, we must make sure that it is the same distance from the second crucial point as the second crucial point was from the first. The third crucial point will fall on the middle y value, which is 30 degrees Celsius, since we are following the pattern of fx equals sine x. Again, we will add a tick on the x-axis underneath the point, but leave it blank for now. The fourth crucial point will again be the same distance away on the x-axis as the previous crucial points have been from each other, except the fourth point will fall at the minimum value, y equals negative 60. Again, we will add a tick on the x-axis above the point. The fifth crucial point will still be the same distance away from the fourth, as the others have been, but will fall on the y-axis on the middle value of y equals 30. Step 2.5. Determine the x values. Determining the x values is a little more complicated. In the information we are given, it states that it takes 12 hours for the temperature to change from the maximum to the minimum. Now, from the points we've plotted, you can see that the crucial points at the maximum and minimum is separated by 3 x-axis ticks, with each tick being the same distance from one another. If the time span between these 3 ticks is 12 hours, there are 2 gaps in between that must be equal in value. We can divide 12 hours by 2 and determine the value between each crucial point must be 6 hours. Now we can label the x-axis values as 0, 6, 12, 18, and 24. Step 3. Determine the equation in terms of sine, giving the sinusoidal function. To determine the equation of a sine function, we need to use the following equation, where a represents amplitude, k represents the horizontal stretch, h represents the phase shift, and b represents the equation of axis. We'll follow these steps to determine the equation of the sinusoidal function in terms of sine. Step 3.1, determine the amplitude. Step 3.2, determine the horizontal stretch. Step 3.3, determine the phase shift. Step 3.4, determine the equation of axis. Step 3.5, putting it all together. Step 3.1, determine the amplitude. Before we find amplitude, we need to understand what it is. Amplitude is half the difference between the maximum and the minimum values of a sinusoidal function. Also, the vertical distance from the x-axis of a sinusoidal function to the maximum or minimum value. We can use the following equation to determine the amplitude. A equals the absolute value of the maximum minus the minimum divided by 2. We note that the maximum value is 120 degrees Celsius and the minimum value is negative 60 degrees Celsius. So we can add that into the equation. So A equals the absolute value of maximum minus minimum divided by 2, which actually is A equals 120 degrees Celsius minus negative 60 degrees Celsius. A negative and a negative equals a positive. So in the next step, 120 degrees Celsius is added to 60 degrees Celsius and still divided by 2, which equals 180 degrees Celsius divided by 2, which equals 90 degrees Celsius. Step 3.2. Determine the horizontal stretch. To determine the horizontal stretch, we need to know the value of the function's period. But what is a period? A period is a change in the independent value, typically x, that corresponds to one cycle of a sinusoidal function. From the graph, we can see that the period of the function is equal to 24 hours. We can now use the following equation to determine the horizontal stretch. Period equals 2 pi over k. We note that the period is 24. So 24 equals 2 pi divided by k. K equals 2 pi divided by 24. Therefore, k equals pi divided by 12. Step 3.3. Determine the phase shift. The phase shift is how far the function is horizontally to the right of the usual position. The usual starting position of a sine function is at x equals 0. The starting position of our sine function is also at x equals 0. Therefore, there is no horizontal phase shift and h equals 0. Step 3.4. Determine the equation of axis. The equation of axis is the equation of the horizontal line that is halfway between the maximum value and minimum value of a sinusoidal function. We can determine the equation of axis using the following equation. Y equals maximum plus minimum divided by 2. We know that the maximum value is 120 degrees Celsius and the minimum value is negative 60 degrees Celsius. Therefore, it would be 120 degrees Celsius plus negative 60 degrees Celsius divided by 2. A positive and a negative becomes a negative, therefore it becomes 120 degrees Celsius minus 60 degrees Celsius divided by 2, which is 60 degrees Celsius divided by 2, which equals 30 degrees Celsius. Therefore, the equation of axis is y equals 30, and the b value is 30. Step 3.5. Putting it all together. We now have all the values we need. The final step is to put them all into the equation fx equals a sine k in brackets x plus h plus b. A equals 90, k equals pi over 12, h equals 0, and b equals 30. Therefore, our equation is fx equals 90 sine pi over 12x plus 30. Step 4. Therefore statement. This is the last step and is very simple. We have now solved the trigonometric word problem, and we must summarize the answer into one simple sentence. Let's reflect back on what the question is asking us to do. What is the equation of the sine function that describes the temperature in this environment? Therefore, the equation of the sine function that describes the temperature in this environment is fx equals 90 sine pi over 2x plus 30. A profession that would use sinusoidal functions would be meteorologist. They would use it to calculate the average temperature over a period of time.